All right, so now I want to talk about how we can stack these planes on top of each other. Okay, I don't know what's going on with that highlighted point, but all right. So what we're going to do here is what I want to know is what is the stacking sequence of this BCC crystal structure. And so we already know that this is the 110 plane. So what I want to do then is kind of expand and draw this out. So I'm going to use my highlighted mark as an anchor. All right, so there is our red plane, and I'm going to place the atoms on it. So the atoms are placed on the corners, no problem. And then also there's the body-centered atom in the middle. There it is. So now what I want to know is where is the plane that lies above or below that, depending on which direction you're looking from. And so the atoms adjacent to this plane are going to be these two guys here, at least within the unit cell. And so we just kind of want to draw these lines parallel. And so we'll draw it like this here. So that is the next plane that's above. And so again, I'm going to draw this in 2 dimensions over here. And so we already know that in this plane, actually I need to fix this just a little bit to make this line up. You'll see why in a second. All right. So here are the planes, or here's the blue plane. So I'm going to already draw in these atoms here. Now let's look back on the left-hand side. Where are the other atoms in this plane? So because these lattices are periodic, you have to think about extending them in all directions. So if you look here, this body center atom, you can translate it up, and it's due to periodicity. Another body center atom will line up there. You can also extend this off to the right side, and so another body centered atom lines up there. And so we can again draw these. So what you see is that the atoms, the blue atoms, lie here, 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 and here on top of the red. And so we can say that this is the B layer, and this is the A layer, and so the stacking sequence, if you think about it in a little bit more detail, it's just going to be A, B, A, B, no problem. I'm going to save progress again. All right. So now for the last bit on this exercise, I want you to think about the directions within a plane. So I'm going to draw some arrows, and I want you to figure out where or what the family of directions is. So in the case for this red plane, let's pick a different color. So I want you to figure out what the direction is here, and you can just use the family of directions. You don't have to specify exactly. And then I'm going to ask you to figure out the diagonal one here. So what is this direction? So fill these in. And then finally this direction as well, going in the horizontal direction. So take 30 seconds to figure out what these family of directions might be, and we'll come back to it. So pause the video and work on that. All right, so to figure this out, what we can do is just kind of relate this back to the crystal structure. So if we label some of the atoms, so this is going to be our anchor atom here, and so I'm just going to draw this as the green one down here. All right, so in the first case, for the vertical direction, this guy up here, so that's going to go from the green, and then it's going to go along the short edge in this direction. So this is a 1, 0, 0 type direction. For this diagonal, it's going to, the diagonal is not going to cross through that green atom. So this is going to go from the top left and down through the body center atom to the bottom right. And so that's going to be a 1, 1, 1 direction. And then the last one, the horizontal, goes from the top left down to the bottom to our green atom. And so that's going to be a 1, 1, 0 type direction. So hopefully that's clear to you. If not, just kind of take another review, take another stab at that.